Hi everyone, my name is Thomas Kim. Today is July 6th, 2020. This is my 43rd episode about the programming language C++ 20 standard. And this is the last episode for this series. In this episode, I will discuss limitations of C++20 standard. First off, C++20 standard does not include type list functions. Type list functions are very useful for advanced template metaprogramming. Secondly, C++20 standard does not yet support static or compile time reflection. Static or compile time reflection will be introduced to C++20 third standard from ISO C++ home in this website. Current ISO C++ status in this website. Reflection is scheduled here, but it is not yet included in C++20 standard. I believe reflection will be introduced to C++23 standard. Third, C++20 standards parallel algorithm does not yet support exceptions. Fourth, C++20 standard does not yet support GPGPU programming. GPGPU programming has been tested over a decade now. Of course, we can use third-party tools such as OpenCL or CUDA or even AMP. However, libraries such as SQL become part of C++ standard. GPGPU programming would be much more accessible for most C++ programmers. This list can go endless. But even though with these limitations, I still believe C++ is the best programming language that humanity ever created. In this episode, I will discuss first two items, type list functions and compile time reflections. Without further ado, let's get started. Start Visual Studio Code. Open your working folder. Click this button, 043, Limitations. Hit enter. Click this button, limitations.cpp. Hit enter. Ctrl V. Include talkplay fun, output HPP, namespace, types, talkplay fun, types, talkplay fun, stream, stream, auto, endl, talkplay fun, endl, void, test, type list, functions, int main. I will copy this function, copy, paste it here. I create a type list using list t types, type list t. In this list, int long double. We can display the elements in the type list like this. String types list t. List t, we provide an instance and there. Now start your command prompt. dir cd 043 limitations. We will be using clang compiler std C++20 limitations.cpp ltbb o c.exe. Hit enter. clsc. This type list include elements int long double. Now we want to test if certain type is included in this list. Stream is short in the list we can test types is type in list B short list T, and then I will copy once again is int in the list. It should be int. Now we build once again. Now this time I will use GNU G++. Hit enter. CLS C. In this list, type short is not included, so the result is false. In this list, type int is included, so the result is true. Now we want to extract the first type using first t types first type list t stream first type talk play fun get type name first t. Now we want to extract second type from this list like this using second t types select nth type 1 list t stream second type talk play fun get type name second t. Now we want to extract the last type like this using last t types last type t list t stream last type talk play fun get type name last t. Now we build once again CLSC. From this list, the first type is int. The second type, long integer. This is the second type. The last type is double. We can extract type elements from this list. Now I will define another type list using types t types type list t short int unsigned short double int float stream types are types t and L. Now we build once again CLSC. So from this type list, we want to remove repeated type. Short int, we want to remove the second short int. Int, we want to create a list that includes unique types like this. Using unique types t types unique types t stream unique types are unique type t and there. We build again CLSC. So from this type list, we remove the int. Repeated int is removed. Also, short integer, any repeated types are removed. It contains unique types. Type list functions enabled me create arbitrary, complex template metaprogramming. All these type functions are defined. Right-click, go to definition. In this file, talk-play-fun types.hpp contains all these functions. I will close this file. Now let me discuss second limitation, compile time reflection. Here, I will create another function, void test reflection missing. I will copy this function name, copy, paste it here. Suppose we want to interrogate if a certain member is supported by a class. Template, type name, class name, concept has MA. This is concept. We can use requires. Don't forget semicolon here. Class name obj MA. This is simple requirement. I will define a class A public int MA. I define another class B. It does not have member MA, but it has a member MB. Now here, stream, does class A has member MA? We can test like this. Has MA? This is concept. Class A. And there, I will copy once again. Paste. Does class B has member MA? Class B. Now in the command prompt, we build again CLS C. So class A has member MA, true. Class B has member MA, false, because class B does not have member MA. This approach is very tedious. If this class has a number of distinct members, this approach does not work. Now we can think of defining macros like this. Define talk play fun has member class name member name. Template type name. We don't need a class name here. Class name concept has a member name requires class name obj member name. We defined has member macro. Then using this macro, talk play fun has member MB. With this definition, here stream does class A has member MB has MB class A, and there I will copy once again. Does class B has member MB class B. Now we build again CLSC. So class A has member B, false, because class A does not have member MB. Does class B has member MB? True, because class B has member MB. Sorry for my broken English. Does class A have a member MA? I will fix like this. This approach is very ugly. Also, it does not expand well. If reflection is introduced to C++, I wish such problem should be resolved in future C++ language. This is the last episode about the programming language C++ training standard. In future episodes, I will film videos about mathematics, especially partial differential equations and Fourier transformations or FFT. Please subscribe to my YouTube channel. Thank you for watching.